Our day doesn't start without seeing a mobile phone or a smartwatch for daily updates because we need to check our friends' messages, we need to see what's the time, we need to see what's happening, what all messages everybody is being uploaded, what all forward messages we have. All these we are very interested in. So we does all these operations, will be doing all these operations either in our mobile phone or laptops or tabs, whichever are convenient. So for every device, we will have some software which is supporting our applications. Like for example, we have different kinds of operating systems. Apple OS is used in our device, Apple laptops or tabs. Linux is another software. Windows we will use in almost all, everybody will be using in our systems. And iOS will be used in our mobile phones. Android, you see Android everywhere in your televisions, in your mobile phones, in your um, all devices which are used for communication. Same as you have another operating system, Ubuntu. So we'll be discussing about different kinds of operating systems, their functionality, and the basic goals, all these in the coming slides. So before this, I am Jayashree. Welcome to Easy BTech. Right, what's the basic concept of operating system? What is the basic concept of operating system? How does it run? You can understand by seeing the image here. A user is using a computer and somebody is there in between for communication, right? So the definition, basic definition which is given is it is an interface between the user and computer hardware from user's view. And OS is system software that manages computer hardware resources. It is called as a resource manager or resource allocator. Okay. Now this is all definition. You feel it so complicated and you don't understand. So let's not make complicated. Let me make it very easy to you in understanding. See the diagram here. Hmm. Yes, I have the first component, hardware. Hardware is compiled of resources. What are resources here? Your CPU, your IO devices, right? CPU is nothing but your central processing unit. Your input output devices. What's an input device? Input device is your keyboard, your mouse, right? Whichever is you are giving it as input is your input device. Output device is your monitor, your speaker, your printer. Okay, now all these are resources which acts as software, which acts as computer hardware. Next level is operating system. Let us not enter into it as of now. We'll see it very carefully and understand. Next level is application program. What is application program? We have users at the other end, right? Each user will be giving one particular operation to the application program. Like one user tells compile my program. It will, what is a compiler? Compiler is something that in languages like C, C++, Java, you will have programs written in it and you have to compile it. So the user will ask to compile my program. Okay. Next is Next user comes with an request as text editor. What does that user tell? You edit my text. That is, you open my document, you go to editor, modify, I'll alter whatever corrections I have to do, and then I will save it. I will close it. All these operations have been done, okay, by the user, and he is saving it, right? Next, the other user comes and tells that I need a spreadsheet. Spreadsheet is nothing but your Excel. What happens? Your system will open a spreadsheet, which is in a tabular form, and the user will perform all the calculations in it and save it. Okay. Now, what is happening here? User is coming, giving a request, that is, opening an application, modifying it, closing it, manipulating, so on. All these requests are given to application program. Okay. And application program is responding to the user. In case if operating system is not there, what happens? User has to communicate directly with the hardware. Now user has to write program for each request in an hardware understandable language. User will write a code program for text editor. He will ask, I need a compiler. He'll write a program in an hardware understandable language, and hardware receives it. It will understand and reply it. Now user cannot do programming for each and every request. For this problem, operating system will act as an interface between hardware and application program, stating that whatever user is requesting for, application program will take all the requests by the user and it sends to the operating system. Now here operating system acts so well that it will allocate the resources appropriately from the hardware and responds to the user. Now it makes the user's life easy. Okay. Another example. Now if you're sitting in front of system and you want to browse something, you will open an browser. Okay. What are browsers? Browser is your Mozilla Firefox, Chrome, right? You open a application, you open a browser and you request for something. If your bandwidth net everything is fine, you get an immediate response. You get a Google page and you search, you'll get the reply, right? If the bandwidth is not sufficient, your net is not proper, what happens? You don't get a reply. You keep on sitting and you wait for the display. User will be irritated. He cannot wait. User cannot wait. He needs a immediate reply. Okay, for this user's convenience, operating system is acting as an interface for efficient and convenience to the user and performance of the system. So now let us see the definition. This acts as an interface between the user and computer hardware. Okay, interface between user and computer hardware. Okay, and operating system is system software. Operating system is system software which manages computer hardware, nothing but your CPU, input output devices. It is called a resource management or resource allocator, which controls the efficient execution of users' programs. Okay, clear? I think the definition is clear for you now. Okay, right. Now, Okay. Now, what are the resources? And um, in case if my operating system is acting as a resource manager, hmm, there are two basic things here. There are two basic things. What is that? It manages and protects multiple computer resources. Manages and protects multiple computer resources. What are resources here? Resources are nothing but your CPU, processors, internal external memory, tasks, applications, users, communication channels. ఓకే, ఇవన్నీ కూడా ఆపరేటింగ్ సిస్టమ్ ప్రొటెక్ట్ చేసుకుంటూ ప్రాపర్గా మేనేజ్ చేసుకుంటూ ఇట్ విల్ ప్రొవైడ్ రీసోర్సెస్ టు ఇన్ అండ్ ఎఫిషియంట్ మేనర్. రీసోర్సెస్ అంటే మన సిపియు, ప్రాసెసర్స్, ఇంటర్నల్ ఎక్స్టర్నల్ మెమరీ, టాస్క్స్, అప్లికేషన్స్, users and communication channels is nothing but your application software. So communication channel. Okay. Second, multiple programs run at the same time. If multiple programs are running at the same time, example processor time అనుకోండి, memory అనుకోండి, IO devices, all these, for all these, running time is same and space is also same. Okay. This decides between conflicting requests for efficient and fair resource use. Here it is very clear that it maximizes the throughput and it minimizes the response time. Why does it minimize the response time? Because the user should be in a convenient mode. He cannot wait for a long time. He'll be frustrated. For that, for that, the response time should be minimum and the throughput should be maximum. Okay? I think this is clear for you. Okay. Next. Let's move on to the goals of an operating system. What is the basic goal of operating system? అసలు ఎందుకు యూజ్ చేస్తున్నారు? యూజ్ చేసిన దానికి గోల్ రీచ్ అయిందా? Or is that something which has to be filled? What is the basic goal? The primary goal of operating system is to provide convenience. The primary goal of operating system is to provide convenience. Okay? A user cannot directly give instructions to the hardware to perform various operations because it is very difficult for the user to convert its request or instructions into machine language that is used by the hardware components to understand the instructions. Right? In case, the same thing, if the user is directly communicating with the hardware, it is difficult for the user to write each and every program in hardware and give it to the hardware. Instead, OS acting as an interface, it will make the user sitting in a convenient mode. That user will just order something and operating system will fetch the resources from hardware and give it to the user. Okay, now here my user is in a convenient mode. Yes, he is in a convenient mode. So the primary goal of operating system is achieved. Okay. The second goal. What is the second goal? It should act efficiently. It should act efficiently. That is, if user wants to perform a number of tasks, then it will be difficult task for that user to use the hardware efficiently. The operating system ensures efficient use of memory, CPU and IO devices. Here my operating system will act efficiently to the hardware in providing quick response to the user. Okay, now my second goal is achieved. My operating system is acting efficiently in providing resources to the user and the user is happy. Okay. Next, functions of an operating system. There are many functions. There are many functions out of which we are discussing about few, like process management, memory management, file management, device management, security management, and command interpreter. What is process management? Process management అంటే ఏంటి? Program CPU ఏదైనా ఇన్స్ట్రక్షన్ ఎగ్జిక్యూట్ చేయందే ప్రోగ్రామ్ ఏ యాక్టివిటీ రన్ చేయదు. Okay, I'll repeat. Program does nothing until its instructions are executed by a CPU. The operating system is responsible for the following activities in connection with process management. Right? Clear. Program does nothing until its instructions are executed by CPU. What are those? What is operating system responsible for? What are the activities? Like scheduling processes and threads on CPU. Scheduling processes is nothing but one process at a time. I want to write a Word document. I want to browse dictionary. I want to browse my content for writing a paper. Okay. Now all these are processes. These processes will run. These are threads. Okay. Process is a thread. Now creating, scheduling all these processes one after the other and threads on the CPU. Processes ni proper ga schedule cheyadamu and threads form lo CPU lo run cheyadam. Right? That's the first activity which is responsible. Second, I will create, process and delete. I will create a process and delete a process. Both user and system process. Okay. Now here I can even suspend and resume my process. Okay. Now I will provide mechanism for process synchronization. I will provide a few mechanisms for process synchronization. What is synchronization? Is, say you are installing an app in your mobile phone. Okay. Any app. For your more understanding, many of us will be using, WhatsApp or very familiar social medias, Facebook or so on. Okay, what do? You install an app. What does it ask? I have your rules and restrictions which are predefined. If you are compatible, if you are okay with my rules, he'll give a small checkbox. You need to click on it. If you click on it, you are attempting that you are okay with all the rules what he has given. Right? And you are in sync with that rules, that you are following it. That is called synchronization. Somebody will be giving a predefined rules and the users who are coming are synchronizing to that particular rules. It's called process synchronization. I have a process and other processes are synchronizing to it. That's called process synchronization. Process synchronization and process communication. What's process communication? I have a process, that's I am running a process and I am waiting for response. I am waiting to get a response. That is communication. I am requesting and I am waiting for a response for my request. That's process communication. All these process management will be providing mechanisms to do all these activities like creating, deleting, suspending, resuming, synchronizing, communication, and so on. Okay, I think process management is clear for you. Yes. Next, memory management. Memory management enti? What all activities are done in memory management? All this, what we are uploading videos, everything is stored in cloud. In cloud, we should have some memory, we should buy some memory, and in case if we are updating it, we need to move some data outside and get new data into it. That's called upgrading our system. So on. Is it? I think some of you have been knowing about this. Memory management is nothing but an operating system does the following activities for memory management, like keeping track of which parts of memory are currently being used and who is using them. Okay, keeping track of which parts of memory are currently being used and who is using them. Deciding which processes, parts of processes, okay, which parts of process and data to move in and out. I have a memory. Now so and so slot have been moved out and so slot have been saved in. Right? So memory management will be having track of all these and allocating and deallocating memory space as needed. I will allocate, say I am opening a Word document, I am writing something on it and saving it. So for that document .doc, abc.doc, when I save it, some memory space will be allocated in my hardware. Yes. So the basic activities of memory management is it will have a track of what memory is going out, what memory is coming in, and allocating, deallocating memories. It will have a track of who is using it, for how much time, and so on. Okay, that is memory management. Next, file management. Yeah, file management is nothing but operating system is responsible for the following activities. What are they? I will create a file, write something on it, or I will open a file which is already saved. I'll open the file, I'll modify it, I'll have some changes in it, and then save it. Save back to the same place. Some slot is allocated to my file. Yeah, that directory will be saved in the same place where it is allocated. Now I'll create a file and delete a file, and same happens with creating and deleting directories to organize files, supporting primitives for manipulating files and deleting. I'll map files onto secondary storage, mapping files onto secondary storage. I'll have a backup. Say I am changing my SIM from one mobile to the other mobile. So what do? First, I'll take a backup of the data what I have in my mobile. I'll take a backup and then move my SIM to other mobile. Taking backup, what does that mean? I am not losing any of my data which is important for me, right? Now, this backing up of files is stored where? In my non-volatile media. What is non-volatile media? Which is stable, which cannot be changed, is non-volatile, right? These backing up files, where are you saving it? It in stable storage media. Stable storage is nothing but your non-volatile media. This is how your file management saves or does activities on your operations. Next, device management. Now here device management is, you can take it as an example. It Your mother will have a track of whom are you talking to, or where are you going, at what time what will you think, at what time what will you do, what is needed for you at what time, food in a proper time, drinking of water, providing water for you in time. All these your mother does at home, right? Same way, device management also controls all the devices attached to the computer. Operating system also controls all the devices attached to the computer. My hardware device are controlled with the help of small software called device drivers. Without device drivers, you cannot do any operations. So here we are using a software called device drivers to control my hardware devices. Okay, and my device management will keep track of all the devices. Programs which are responsible for this task is called IO controller. IO controller is responsible for all the programs which are done in the device, and it will keep track of it. And it decides which process gets the device when and for how much time. My device management will decide which process gets the device when and for how much time should that device stay in that particular process. Okay, and allocates the device in an efficient way. Same way it will deallocate after the job is done. Right? Next comes protection and security. Protection and security. Now this is important. Now there comes something very important to everybody's system or mobile phone, any device. Right? Now if user is trying to access an unauthorized data, okay, now I am a user. My user identities like user identities, security ID. Now this includes name, associated number, one per user. Now user ID then associated with all the files. I will have access to few files where I have saved it. I will not have access to some other files, some other user files. Okay. Now if I have to access my file, I should have a user ID authenticated. Now I will use my uh, ID and access my file. Example, I have to open my Gmail. I have to give a user ID and password. Now my user ID and password, if I give you, my mail will be open. Same as I cannot use some other's email ID and try to open their mail. Okay, that is called protection. Your operating system is protecting your system, or the user is being protected with a user ID. Okay. Now my access control determines what all files, processes does the user is having access to. Other thing is, I'll have group identifiers. Like I'll have ID for a group wherein only that group can access the data which they have stored. In that way, I will provide protection. Okay. Next is privileged escalators. Privilege escalation is nothing but I have a problem, user is having a problem, and that is not being rectified. Then that is put into a priority. That's called escalation. Privilege escalation allows user to change to effective ID with more rights. So clearly, protection is nothing but your controlling access. Access is being controlled without being giving your access to everybody. And security is nothing but it will protect the system with internal and external attacks from viruses, worms, identity thefts, thefts of services, denial of services, and so on. Right? Next, command interpreter. The last functionality is command interpreter. In fact, not last, but in the list which we have been discussing, in that the last function is command interpreter. This command interpreter is an interface between a user and machine. The operating system offers two types of interfaces. One is graphical line interface, second is command line interface. Graphical line interface is it interacts with visual environment to communicate with the computer. It uses windows, icons, menus and other graphical objects to issue commands. Right? Next is command line interface. Second is command line interface. Now this provides an interface to communicate with the computer by typing commands. I think both are crystal clear. Graphical line interface will be using it for windows, icons, menus and other graphical objects which are there on our application. All the other operations we do on it is a graphical line interface. Command line interface is I will give a command. I will provide an interface to communicate with the computer by typing a command. Okay, right. Uh, so let us have a quick summary on what we have discussed. We have discussed about the basic concept of operating system, the functionality, the structure of operating system, and the functionalities of it. Yes, we have seen six different functions. One is process management, memory management, file management, device management, security management, and command interpreter. And we have also discussed the basic goals of operating system. What are the goals? Primary goal is convenience, secondary goal is efficiency. I think you have got some idea about operating systems. For this session, we'll end and we'll meet in our next session. For more such videos, uh, please do subscribe to EasyBTech. Thank you.